Hello there. Thanks for dropping by. So let's just go over uh, the entire hardware setup of our project right here. Okay, so basically, you can see right here we have the Raspberry Pi 3 motherboard. Let's just call it the motherboard, and we got a bunch of wires connected to different sensors, USB, some other sensor over here, camera. Let's go over this one by one. So let's look at this over here. So I got these sensor breakout boards connected to the breadboard I have over here. And let's go over here first. Let's look at this guy. Okay, so this is a breakout board that houses a luminosity slash light sensor. We're using a TSL 2561 chip. So basically, this one detects the amount of light in the room, and it will communicate to the Pi across I2C. Okay, so and the next guy is this guy right here. So this is a breakout board that houses a Silicon Lab 7021 chip. This chip measures a combination of temperature and humidity. So again, this chip also communicates to the Pi through I2C. So as you can see, I have jumped the communication lines for these two together because they're both I2C, and then they're tied to the I2C lines of the Raspberry Pi. And we're using the I2C1 module for the Raspberry Pi. Okay, so that's it for these two. These two will take care of the light and temperature slash humidity. So next we have these two guys. So let's talk about this guy. So this is a breakout board that houses a chip that measures the amount of alcohol slash carbon dioxide slash gas level in the room. So it doesn't break the measurement out individually. It's some kind of combination of these components. Okay, so basically the output of this guy is a raw voltage, raw analog voltage. Okay, so we have to somehow convert this to a digital voltage, not digital signal, so the Raspberry Pi can understand. So the thing about the Raspberry Pi is that it actually does not have a onboard analog to digital converter. Okay, so that's one small drawback for Raspberry Pi, and as opposed to the BeagleBone Black has so many ADC DAC. So basically, what we do is we have to take this guy over here. You see, this is a discrete analog to digital converter. So we're using a microchip 12-bit ADC. Okay, so the output of this guy is connected to the input of one of the channel of this guy. Then the output of the ADC is a 12-bit digitized signal. So we're pushing the digitized signal to the Raspberry Pi via SPI. So this is the communication interface to Raspberry Pi across SPI. So we're using SPI 0 on the Raspberry Pi. Okay, so that's that for the breadboard over here. So this region is what I call periodic sensor data. What I mean by periodic is that we're actually periodically retrieving or gathering the data from these sensors. Okay, so we're talking about the light level, the humidity, the temperature, and the air quality. So these four things we periodically get the data. Okay, so where the heck do we put it? Okay, so you see right here we got this USB dongle over here. So this USB dongle contains a SQLite database, and then periodically, as we get data, we will save it onto the USB dongle. Okay, so you say, well, why not save it onto the Raspberry Pi? It's like internal memory or something like that. Well, there's a reason for that. Okay, so something that I explained in the blog. But basically, right now we are saving this data into this USB dongle. Okay, periodically. Now let's go look over here. Now over here we got a 8 megapixel camera. So this is the official Raspberry Pi camera module. Okay, I mean official means this is made by the same people who actually also made the Raspberry Pi. So they made it real simple. So this ribbon connector connects to the onboard connect over here. This is what they call a serial camera interface. Okay, so very easy to connect, and there's drivers that come with the Linux distribution for the Raspberry Pi already, so very easy to hook up and run whatever. So for me, we're using this camera for two purposes. Okay, one is to live stream the room, constant live stream. So for that, I'm actually using an open source library, which I'll talk about in the blog. Number two, we're gonna capture/record a 10-second video whenever we sense some kind of motion in a room. So that we take the same string that this camera is live streaming, but whenever we get trigger for motion in the room, we record a video off the string for the next 10 seconds, convert it to MP4, and then we save it back into the USB. So now the USB houses the SQLite database for these sensors as well as saved MP4 clips. Okay, so how do we get the motion trigger? Well, we got this guy over here. Okay, so look at this guy. What the heck is that you say? Some kind of honeycomb? So this guy is what they call a PIR sensor, standing for passive infrared. Okay, so inside this bubble, there's a little tiny sensor that senses infrared in front of it. Well, not just in front, but there's a range, and then it'll sense a difference infrared, and it'll trigger a output binary signal if it senses the motion. So basically, this guy's got three connectors: power, ground, and an output. So the output is binary. When nothing's there, it's 0. When it detects something, it goes to 3.3 volts. So we're connecting this guy to one of the GPIOs on the Pi, and using that as an input, we can sense whenever the sensor triggers motion. So we'll talk about this. We're gonna write a little Linux kernel module device driver on the kernel space where it'll handle the what's gonna happen is we're gonna have an interrupt and handle the interrupt when the signal goes high, and after that we're gonna trigger another signal for the user space to handle further. So it'll be another good learning experience. And so that's that. Okay, so overall that's the whole gist of it. And then over here we got the 5-volt power supply to the wall plug, and finally so the good thing about Raspberry Pi 3 is we have an onboard Wi-Fi / Bluetooth combo chip from Broadcom, so we don't have to add more dongles on the back here. So that was a good thing. So basically, in summary, our hardware over here, we collect the sensor data over here. We can stream over here. We collect the motion trigger here, and we save it onto USB. But through Wi-Fi, the Pi is connected to our router at home, and the router is connected to the internet, obviously. So, say I can be at work, I'll type in the domain name or the IP address of, my home address, the IP address, and then we can log in with the user and the password, and then we can pull out the data from the stuff saved on the USB. So that's the whole gist of it. This is an IoT device connected to the internet through Wi-Fi, and then anywhere in the world we can go on a browser, type in the IP address, and we get logged in here, and then we can take a look at what's going on, what's the current temperature, what's the current air quality, what's going on. Take a look at the stream, see if anybody, I don't know, if your cat moved or you had a burglar and triggered a motion or whatever. So that's the whole gist of this project. Okay, so the next video I'm gonna go over the browser side of it. So this is the kind of the hardware setup and the kind of low level what's going on. So the next video I'll talk about the GUI side. So I'll be going over logging in here on the browser side and go over all the modules and what it looks like and how we can actually retrieve these data and manipulate them. Okay, so okay, thanks for watching. Talk to you later.